Let us solve the exercise number 2 in the part B of data structure lab. In this exercise, we are supposed to write a program to implement a circular queue using arrays. Now, what is this circular queue? Circular queue is a queue which has no ending. So that means to say that you can keep on inserting the element continuously in a circle. And if there is any vacant, you can still keep on adding it. So there is no end to this particular circular list or circular queue. However, this circular queue is implemented using the linear array because in C we don't have something called a circular array. As usual, for whether it is a circular queue or whether it is a normal queue, in the beginning, that is during the initialization, both the front and rear pointer will be pointing to -1. This indicates the queue is completely empty and there are no elements are there in the queue. How do you start adding the elements into the queue? So the minute you add the first element into the queue, you move both the front pointer as well as the rear pointer to point to the same location. When you want to insert the new element, you first move the rear pointer by one location so that it points to the next vacant location, and then you fill the values. If you want to insert one more element, you first move the rear pointer and then fill the element there. Again, you do the same thing. You fill the element and you keep on doing like this. So this is how you fill. Let me do that thing. Okay, let me fill one element over here, and finally you move it and we fill the element over here. So that means to say that all the elements are filled. So this is one condition wherein you notice that the front pointer is pointing to the first index, that is the 0th index, and the rear pointer is pointing to the last index. Okay. If this is a scenario, the queue is full and you cannot add any more element into the queue. However, you can always remove an element from the queue. So if you want to remove the element, you just move the front pointer to the next location. So it assumes that virtually it means to say that the first element is vacant and you can add an element into the queue. Okay, so because the first element is vacant, you can add the element into the queue. What do I mean by saying that is, suppose if you want to add this one more element into the queue is so when the rear pointer has reached the last position or the last index, and if you find that the first index is vacant here, so the element at the first index is vacant, what you have to do is you have to move this rear pointer back to the front side. So you move it here. In other words, you reset this rear pointer back to the location here. So it will point to this location. And then, as usual, because it is vacant, you can fill it with the any element. Suppose if you want to delete an element, you move the front pointer to the next location. So from the index 1, you move it to the index 2. That means to say that the element at here has been deleted. In the same way, you move this pointer to the next location. That means to say that virtually this element is been deleted. Now, if you want to add, again, you just move the rear pointer by one location and you will be able to add a new element here. Again, move the rear pointer one location and you will be able to add one more element. Now you notice over here is that the next element of the rear, so in front of the rear, you have the front pointer. So this, when you look at this one, you notice that all these are filled. All these are filled. That means to say that the entire queue is filled. So this is the second scenario wherein you notice that queue is full. So there are two conditions where the queue is full. What are the two conditions? One is when the front pointer is pointing to the 0th index and the rear pointer is pointing to the last index. So this is a scenario, the queue is full. Next one is you have deleted your some element from the queue, and you notice that and you started filling. So the rear pointer came back and you started filling, and what you notice is the rear plus 1, rear is 2 now, rear plus 1 is the front location. So rear plus 1, rear is pointing at 2 now, rear plus 1 is going to be the location of the front, either here or here, anywhere. Rear plus 1, if it is equal to front, that means to say that queue is full and there is no more vacant element at this particular queue. Let us use this in our program. So I have taken the liberty to start a new C program, and you know, if you have not understood how to create a program in the how to start a C file in code block, watch my other videos. So let me start the coding here. So I have the, I'm going to start include stdio.h. You can give any name to the file as such. The name is US. So let us create a constant called as size, and I'm going to keep the size as 5. And as usual, let me assume that the queue is integer of size as declared over here. So the size is 5. And initial stage, when there are no elements are there in the queue, what is this happening? Okay, so let me delete it. So initially, both the front and the rear pointer will be pointing to the value -1. So this is the initial setup. So I'm going to make it as initially front pointer is -1 and rear pointer is also -1. Let me write the function to insert it. Some people call it as enqueue. Okay. And I'm going to call it as just insert because that will be the easiest word to remember. So I will call it as insert an element into the queue. So what is the first thing? First thing is just check whether there is a space. Whenever you want to insert something into the queue, first assume or assure that all the there is at least a vacant place where I can fill the element. If you notice that all the elements or all the positions are already filled, that means you cannot insert one more element. So first, whenever you want to insert, you first check whether there is a place to insert. In other words, whether all the locations are filled. In the same way, when you want to delete an element, you check whether there is at least one element that can be deleted. That means not all the entire queue is empty. If the entire queue is empty, you can't delete it. In the same way, if the entire queue is full, you can't insert it. So let's first check whether the queue is full. I told you two scenarios. What are the two scenarios? First one is the front is pointing at 0 and the rear is pointing at the last element. So if that is the case, then I say that the queue is full. So if the front is pointing at 0 and rear pointer is pointing at size -1, the reason for size -1 is because you know very well in C the array index starts from 0. So this is 1 less than the total size of the array, so size -1. Or there are two scenario. What are the two scenario? One is front is pointing at 0, other the rear pointer is at the last location. That means this queue is full. The other scenario is rear is behind the front. So this is the other scenario. So you started inserting additional element and you came here and the front is already full. So you notice that there is no more vacant place available. So if rear plus 1 is equal to front, that is also a scenario wherein you say that queue is full. So if the rear pointer plus 1 is equal to front pointer, that means to say that the queue is full. So I'm going to say printf and I'm going to say /n queue is full. Okay, so I'm going to just put that thing. Otherwise, we will have to insert the element into the queue. So how do you insert the element into the queue? So let's look at that particular thing. Okay. So before we insert an element into the queue, so generally what you do when you try to insert an element into the queue. To insert an element into the queue, let me bring the scenario over here. You first move the rear pointer to the next location. Suppose, suppose you have a scenario. Let's say this is the scenario. You have filled up to here. Now rear pointer is there at this. So you move the rear pointer to the next location and then fill the element. So you move the rear pointer to the next location, fill the element. You move the rear pointer to the next location and fill the element. Now, because it is a circular cube, it can go back and start filling from the beginning also. Suppose if you have deleted, let's say, if you have deleted few items over here, so the rear pointer is there and the front pointer has come up to this point. So that means there is a vacant location in the beginning. So the rear pointer can now go back to the beginning. So how do I write that particular thing? You have to take care of that thing. So if the rear pointer is there at the last location, that is one thing. And very, very important, if the front is there at the zero location. So that means to say that, let me just fill a few element over here. So if the front is there at the zeroth location, that means no elements are being deleted. So I cannot move the rear pointer back to the front. This is not possible. Suppose if the front is not there at the zeroth index, front has also moved. That means to say that some elements were deleted after insertion. In this case, the front is not pointing at the zeroth location, but rear is pointing at the last location. In that case, I can think of moving this rear pointer to the beginning here. So how do I write that particular thing? So I'm going to say if front pointer is at, sorry, it is not, a front pointer is not at the zeroth location. Okay, and let me put it like this so that it looks beautiful. And okay, the thing, this bracket is not, I think that bracket is not really required, but I'm going to just put that thing there. Okay, it's not really required. I'm going to remove it. Otherwise, during the examination, you will, some of you will end up in no getting confused with the number of brackets. That brackets are not really required. So the first condition is this rear pointer is this front pointer is not pointing at the zeroth location. It is pointing somewhere else, but rear pointer is pointing at the last value. So that it means to say that rear pointer is there at the last index value. So, and let me put that, and rear pointer is pointing at the size -1. Again, let me tell you size -1 because we are starting the array from the 0 index. So this will be, last index will be 1 less than the total size. You are already familiar with that. So if this is a scenario, what you can do is you can move this rear pointer to the location here. Okay, so to the location here. However, I will make the rear pointer -1. So you may ask, why are you doing this as a rear pointer as equal to -1? What is the reason? I'll tell you what is the reason. Why did I do rear pointer is equal to -1? The reason for that is how do I add the new element into the list? So let me tell you, how do I add the new element into the list? I add the new element into the list by incrementing the rear pointer to the next location. So the first thing I do is I increment the rear pointer to the next value and then add it. So suppose if I bring this pointer to 0, what is the general scenario? I increment the right pointer and then fill the value. So what will happen is that this will be vacant. So what I'm going to do is I'm going to bring this here to minus 1. So what is the general criteria? Increment the right pointer by 1. You get the vacant location and fill it. So this is the general idea. How do you add a new element is you increment the right pointer by 1 and you fill the element. So right pointer is pointing at minus 1. Increment the right pointer by 1 and then fill the element. So this is what I'm going to do. That is the reason I made this one as a right pointer as minus 1 so that it comes to back here. So I increment it by 1. So minus 1 plus 1 is 0. So it's going to point at this 0th location. And then I fill the element. So in order to fill the element, I will have to ask the user what is the value of the element. So I'm going to use a printf statement and ask the user, okay, what is the value? And also, if you don't like this, you can, again, this is optional. You can write it in a single line. Okay, so this is optional. If you want, you can do it. Otherwise, just leave it. If it is confusing to you, some of you may get confused with the statement. If I write it in a single line, it is possible to write it in a single line. There is nothing wrong in it. So let me write the printf statement, and I'm going to say /n, enter a number, and put a space here. And I'm going to read the element. So to read, you know very well, you use the scanf, and I'm going to use the %d. And I have to I have to put it at the q is named as a. So this is my q, that is the array. Okay. So a of we do is we first increment. Suppose if this is the pointer, and if I want to do this, first increment the rear pointer and then fill the value. So how do I write that thing? First increment the right pointer. So increment the right pointer and then fill the value. So this is what I'm going to do. Increment the right pointer and fill it. Definitely I have missed the ampersand sign because you know very well in C, whenever you want to add the element, you have to give the address of the location. So that is it. Now the general thing, the other thing that can happen is when you try to increase the value. So let's look at the first scenario. Let me remove all of them. Okay, this is the special case. This is some special case. So in the beginning, when the queue is completely empty, how do you insert an element? First, increment the right pointer so that it points at this location and then fill the value. So this is what. Increment the right pointer and then fill the value. So this is what you should do. Now let's come back to the initial scenario. When you want to fill the first element, increment the right pointer. Remember, right pointer is now pointing at -1. So increment the right pointer by 1. So it will point to f0 here. Okay. Fill the value. Now what is the next thing that you have to do is, now you have a wrong scenario here. The front pointer is still pointing at this one. That is a -1. Suppose if the front pointer is pointing at -1, there is one element is already there. So what you can do is you can just move the right pointer to this location. So this happens only in the beginning. In the beginning, when the queue is completely empty, both the front and the rear pointer will be pointing at -1. So when you insert the first element, the rear pointer is -1 plus 1. That is increment the rear pointer. Rear pointer will point here. You fill the element, and because the front pointer is still pointing at -1, you just increment it and make it point to 0. So this is what you're going to do. So I'm going to write that thing. So if front pointer is at -1, then I'm going to write it. See, it's up to you. You can write here in the next line, and then say front pointer is equal to, you can just say front pointer plus plus. You can do this, or if you are a experienced programmer or if you are an experienced student, you can just write it in a single line. It's optional. Both of them are right. Okay, so because some students are used to look at the if statement like this. So you have the if condition and then the value. So that's why I'm writing. Otherwise, you can write it in a single line. So that completes the insertion. Let's try to go with the deletion. So I'm going to go and I'm going to let us formulate the logic for deleting the element. Now, before we delete an element, the first thing that we must do is check is whether the queue is empty. When do you say the queue is empty? If the front pointer is pointing at a -1, that's the initial scenario. The queue is empty. If there is queue is empty, you can't remove any element from the queue. So let's first write that logic here. So I'm going to go here and I'm going to write if okay, front pointer is equal to -1. That means the queue is empty. I'm going to say again, there is no need to write this in the next line. I'm doing it only to help those students who cannot visualize that the things can be written in a single line. Okay. Q is empty. Okay. And then this is the scenario. So this is the one scenario. That means to say that this is the initial scenario wherein the queue is completely empty and you can delete anything. Suppose if the queue is not empty, then what are you going to do? Then you have to first check whether something can be deleted. Okay, so how can I delete an element? So before I delete an element, let me tell the user that I'm deleting the element. So I'm going to go with the else statement. And I'm going to say, first I'm going to use a printf statement and I'm going to say element %d deleted. Okay. Let me use /n just to make the things beautiful. So these are all /n's are new lines are added just to make the things beautiful. So I want to delete from the front pointer. So let me use front pointer FP as my front pointer. Then this will be deleted. Now, how do I move the front pointer? So you know very well, generally you move the front pointer by saying, so how do you delete an element? So let's say you have some values here. Okay, and this is the front pointer and this is the rear pointer. How do you delete the element? You just move the front pointer to the next. In that case, it is deleted. Okay, so this is the idea. Now suppose you want to delete one more element, move the front pointer to the next. This is assumed that this element is deleted. If you want to delete this element, move the front pointer by 1, this is deleted. Move the front pointer by 1, this is deleted. Move the front pointer by 1, this is deleted. Now this is the last element which is there in the queue. So if you move this one, okay, to the next location, that means this element is deleted. Now this is going to create a problem. If you delete the last element, that means the queue is completely empty. How do you say the queue is completely empty? Let's come back to the first scenario. When you started, both the front pointer and the rear pointer were pointing here. Okay? And as you start inputting one element into the queue, you started moving the rear pointer by one location. So this is the okay. So let me just make it here. Let me just put one element here. So you just move this rear pointer one location. This is what you do, and definitely where you moved this front pointer by 1. Now, when you delete it, what you're going to do is you move the front pointer by 1 location. That means this element is deleted. This is the last element to be deleted. So both the front and the rear pointer are pointing to the same location. If both the front and the rear pointers are pointing to the same location, that means you want to delete this element. when you move this front pointer by 1, that means to say that this element is deleted. That means the queue must be empty. So how do you say queue is empty? You come back to the first scenario. You say queue is empty when both the front pointer and the rear pointer are pointing to -1 location. So if this is the scenario, you say queue is empty. So when you delete the last element, and both the rear pointer and front pointer are pointing to the same location, if you want to delete this last element which is available over here, so what you are going to do is you will reset these both the pointers back to this -1 location. So this is what you are going to do. So when do you do that thing? So if both the front pointer and the rear pointer are pointing to the same location, in that case, you will reset both the front pointer and the rear pointer to -1. So this is what you are going to do. So if this is the last element, let's say you have the rear pointer pointing to this location and the front pointer is behind here, and some elements are there. When you delete this element, you move the front pointer by 1, so this element is deleted. Now there is only one element in the queue. When you delete this element, you have to reset both the front pointer and the rear pointer to point to the -1 location. That to say that the entire queue is empty. So this is what is being written over here. Okay, let's look at one other scenario. There can be one other scenario here. What is this other scenario? So let's look at there is the other scenario. So the other scenario is when you have this kind of problem. What is this problem? So let me first insert an element. So you move the rear pointer, you put one element. You move the rear pointer, you put one element. Let me say you have inserted elements like this. Okay. So rear pointer is here and the front pointer is here. You delete one element. How do you delete one element? You move the rear, front pointer by 1. This means to say that the front pointer, that means the element is deleted. So if you move this front pointer by 1, this means to say that this value has been deleted. And if you move this front pointer by 1, that means to say that the element over here is deleted. Now if I want to add one more element, you know very well this rear pointer will come back here. So the rear pointer will come back, and let's say that you're going to add one more element over here. And you delete this element. Let's continue with deleting this element. Move the pointer and delete that element. Move the pointer and delete this element. Now you have this special scenario. What is this special case? You have the front pointer pointing to the last element, that is the size of the array. It's the last, the highest index of the array. Now when you delete it, what is going to happen? The front pointer cannot go to the next. The front pointer now has to come back and point to this location. So if I delete one element now from here, this rear front pointer has to come back and point to this location. That means to say that if you have the front pointer at pointing at the last element of the array, reset this one and bring it back to the index 0. So this is what I'm going to write it here now. So if the front pointer, I'm going to write it here. If the front pointer is pointing to size -1, again size -1 because array is starting at 0. So the last element is 1 less than the size. So you reset the front pointer to 0. So if this is the last element, and if you want to delete this one, you bring this front pointer to the front location. So you bring it here. So that is what is been done. Otherwise, general case. If you, what is the general case? You just increment the front pointer by 1. So how do you delete it? What is the general scenario? How do you delete? Let me assume that there are some elements are there. How do you delete this? Just move the front pointer by 1. This will be deleted. Just move the front pointer by 1. This is that is the general case. Otherwise, front pointer plus plus. So that is it. Okay, that being done, let's go to the, this is the thing that you have to take care. So Q is empty, you have taken care. Let's go to the next one, and that is display. So let's go and let's talk about the display. Hope that spelling is proper. Okay, what are the things that you need to take care? The first one is you just see whether there are any elements on the queue. So if the queue is empty, that means to say that you can't display any element, or you can't list any element. When do you say the queue is empty? Queue is empty is a scenario wherein the front pointer is pointing at -1. So let me write that thing. If the front pointer is pointing at -1, then you are going to say that queue is empty. So I'm going to say slash n, and I'm going to say queue is empty. Okay, so that is the one situation. What about the other? So let's look at the other scenarios. Okay, what are the other scenarios? The other scenario is when we have the front behind the rear. So let's look at that scenario here. What do I mean by saying that is, suppose if this is the scenario, the front is here. So this is the general scenario. You have one element here, one element here, one element here, and one element, let's say here, and the rear pointer is here. So how do you print it? So general thing, you start from I is equal to this, you keep on moving up to I reaches here. So you write a for loop, and you start printing the value from I is equal to that to the other location. So this is the general thing that you're going to do it. So I'm going to just create a variable here for I, because I'm going to use a for loop. You can use anything. So int I. So the first scenario, let me write that first scenario. If front pointer is behind the behind greater less than or equal, let me write that thing, rear pointer. Okay, so that is the scenario. I have used the including that. The reason is there may be a situation wherein you have both of them pointing to the same location. That means only one element is there in the queue. Okay, so if this is a scenario, if front pointer is behind the rear pointer, then what you are going to do is you start with the front pointer. So you can use the for loop. So for, okay, let me use for I is equal to front pointer. So this what is happening. For I is equal to front pointer, and I less than or equal to rear pointer. So this is what you have done it in the ordinary, what is that, uh, array based queue. So ordinary queue that you have created, the general linear queue that you have created. This is the general thing that you would have done it. So I'm going to just say printf, and I'm going to say percentage %d, and one space here, and area of I. So this is the general thing. You just print it from the front to the rear. Now before I print it, I'm going to just put one statement here, one printf statement. Again, this is to make the things beautiful. I'll start with the slash n, and I'm going to say elements in the queue. Yeah, just to make the things look beautiful. That's it. Not doing it otherwise. Just make the things look beautiful. So then that is also counted. Okay, so this is one scenario. What is the other scenario? Other scenario is this is the scenario. You, let's say you have added one more element here. You deleted a few elements from here. So you deleted few elements from here, let's say, and the front pointer, as you delete, the front pointer will start moving here, and you start inserting one more element. So you insert one more element. So let's say you inserted one or maybe two elements inserted here. So now what you notice, let's say this is it. Now what you notice is that this is the other scenario. So this is because the rear pointer has come back and it has traversed. So from the last it has come back. So now you notice that rear pointer is behind the front pointer. So how many values you have to print? So from the front pointer, go up to the end, that is the size of the array. So go up to the size of the array. So from the front pointer, go up to the size of the array. Then from the 0, that is from here, from the 0, go up to the rear pointer. So go up to the rear pointer. So from the front pointer, go up to the size of the array. So up to here, these elements, all these elements. And from the 0th index, from here, go up to the rear pointer. So two for loops has to be executed. So let's write that one. So let me write the else part now. So else, so let me put this one, else for I is equal to front pointer, okay, I less than or equal to, let me say I less than the size, so that will be easiest one. Otherwise, I have to say less than or equal to size minus 1. Instead of that, I will just do less than the size I plus plus. Okay. Print this array. So let's percentage %d and one space, very important, the element of I. So this is this part. What is this part? From the rear pointer up to this size of the array. So up to the size of the array, from here to the size of the array. Then from the 0 up to the rear pointer. So let's write that array. So I'm going to say for again I is equal to 0. This time I is equal to 0. That is from the 0. From the 0 you go up to the rear pointer, wherever the rear pointer is pointing to. So from here, then I less than or equal to the rear pointer I plus plus, and you print the value. So you print this value. So I'm going to say percentage %d, one space, and print the value of a of I. And finally, whether you print it here or whether you print it there, I'm going to use a print /n. Again, this /n I'm putting is so that the things will look nice. So otherwise what will happen is the next prompt will come directly after this. So one /n, so that whatever the numbers, so it may start printing like 10, 20, 30, 40 like this. And after this list, let it go to the next line, so that the next things will printed in the next line. So that's why I'm using /n here. So that completes the display also. Now what is left over with us is did I put all the flower brackets here properly? Okay, so let me see. I think this one is for this one. Okay, and this is for here. I think I missed one flower bracket here. Okay, let me see if it is not coming. I will cross verify. Let's write the main one, and if there is any problem, I will fix that problem later. So let's start with the main problem and the main function. And what are the things we have? We have three choices here. Either you can insert, delete, or display, and the fourth one you can exit it. So let's ask the some choice from the user, and I'm going to use the do while loop here. So do while the choice is not equal to 4, because if the choice is 4, the user wants to exit. Let's write the menu here. So I'm going to use the printf, and I'm going to say /n. The first choice is insert, done, /n. The second choice is delete, /n. The third choice is display, slash n, and I'm going to put dash 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 slash n. Next choice is choice. Sorry, let me put the next choice here, slash n. Choice number 4 is exit, because I have to give an exit option, right? It's not. Choice 4 is exit, slash nn, and I'm going to say your choice. Get done. Let me put a semicolon here. Done with it. Let me use a scanf statement, and I'm going to read %d and ampersand ch. I'm going to read the choice. Let me use the switch statement. Switch on the choices. There are few choices that the user can do. So case number 1, what is the case number 1? Case number 1 is you are going to insert the element into the queue. You can use the enqueue as the word, but I use the insert. After insertion, let's take a break and let's go for the next one. Case number 2 is we are going to delete. You can use enqueue and dequeue word, but I've used the insert and delete. See, it's up to you. Whichever word you want to use it, you can use it. Case number 3 is display. And let me take a break after that. Case number 4, let's write the case number 4. What is the case number 4 is, let me use the print f here, and I'm going to use slash n, and I'm going to say exiting slash n. Okay, and then I'm going to say take a break. And the default case, that is when somebody types something which does not make sense. So print f, anything else, I'm going to say slash n. I'm going to say a wrong choice. And I'm going to say slash n here. So that's it. We have done with that. And let me remove all the extra space that I've added. Okay. So let me try to compile it. If there is any error, let's see. So I'm going to run it now. If there is an error, I will get an error. So if you have this one, this kind of a problem which you don't know what is going on, you will just go to the view and you're going to say logs, and you get error here, print. Instead of print f, I use the word print. So this is print f. Done with it. Okay, let me okay, so if I got the first one, let me try to display, and I must get the queue is empty. Let me try to delete. I must get the queue is empty. Let me insert one element. So I insert the 10. Let me display it here. So 10 is there. I'm going to insert one more element, 20. I'm going to insert one more element, 30. I'm going to insert one more element, 40. Let me display it by typing 3. So you have 4 elements. Look at the queue that I have taken. The size of the queue is 5. Okay. So I'm going to insert one more element into the queue. Okay. And this is going to be 50. So let me show that thing. So this means to say that my array is full. So I have inserted all the elements. So the front pointer is pointing here and the rear pointer is pointing here. Now if I try to insert it, I must get the queue is full. So let me go with the one choice, and what I get is the queue is full. Done. Let me remove the element 10 from here. So I'm going to remove the element 10. Let me press 2 here to delete the one element. 10 is deleted. So you know that 10 is the first element and 10 has been deleted. Let me just display the queue here. So 10 is deleted. Remember, now there is this 10 place which is vacant. I can insert an element there. Let me plus 1 here, and I'm going to put 60 there. Okay, let me show the choice now. So the 10 has been inserted. Remember, it won't come here. it is the queue. So in the queue, you don't now don't think that some of you may think why 10 is not coming. 10 cannot come here because it is a queue. Queue means last element is already there. Even though the queue looks like a, where is the thing gone? Okay, it may look like a circular queue, but it is a queue. The last element is always at the last only. So the implementation may be queue, but it is coming at the end only. Okay. So I keep on deleting all the element. So this is that means it is coming back. I'll keep on deleting one element. So naturally after 60 it will come back. So let me keep on deleting one element. So I said delete the element 20 is deleted. So you know that. Next one 30 is deleted. 40, 50, 60. So let me delete all. So 30 is deleted. So done. Again delete. 40 is deleted. Again delete. Let me just show you what is remaining now. 50 and 60 is remaining. So let me delete 50 is deleted. Let me delete 60 is deleted. Let me delete again. It says the queue is empty. Okay. Let me try to display it and it says the queue is empty. That's all we need to do. So we are able to achieve the circular queue. Thank you for your interest. We will meet again in the other exercise. Thank you.